Good morning. Today we're going to look at how to express one variable inequalities using interval notation. There are different ways to communicate solution sets that include inequalities. First, I'm going to draw a number line to make sure this one's clear. We're going to look at how to take x is greater than 4 and convert it to interval notation. So all the values greater than 4 are included in this inequality, but not 4 itself because there's no or equal to. So we simply circle 4 and shade everything to the right. Now to use interval notation, we're going to have to think about where that ray is going. One way to describe where it's going is that it's going toward positive infinity. Now I'm going to use interval notation to express this group of numbers. When I'm using not equal to, I'm going to use a curved bracket, the reference number, and then I've got to show where this interval is going. Although this looks like a point in the coordinate plane, it's not. This is interval notation, and it's showing the group of numbers going from 4 to infinity, however not including 4. You may notice that I'm using that same symbol for infinity. Think of it this way. Since numbers continue without end, we're saying that you're going through very large numbers, or through infinity, if you will. Now let's look at how to write x is greater than or equal to 6 using interval notation. I think it helps to have the number line to look at first when you're doing this. So here's 6, and this time 6 is included in the solution set because we have the inequality greater than or equal to. So I'm actually putting a point on 6, showing that it's included. Then I'm going to shade everything to the right of 6. Again, we've got to think about where this ray is going. It's going to positive infinity. To show that 6 is included in the solution set, we use a squared off bracket. And again, we always use the curved bracket in interval notation to show that we're kind of going through infinity, or through the largest numbers that we're kind of aware of. Now let's look at what you do if the ray is going in the other direction. If your inequality is, for example, x is less than 2. Since 2 is not included in the solution set, I just circle it to show that's my reference point. For example, 1.9 would be a solution, but just not 2. Everything less than 2 is included in this inequality. Then we have to decide where this ray is going. We're going to describe that as going through negative infinity. So this time our interval begins with negative infinity and ends just before 2. So 1.9 is the solution, 1.99, 1.999, but not 2. Now let's look at a very similar inequality in which the reference number is included. So in this case, all our x values that satisfy this inequality statement are less than or equal to negative 3. Which means I am actually putting a point, including negative 3 here, and shading all the values less, all the way through negative infinity. Remember to always use the curved bracket for positive infinity or negative infinity. And since our negative 3, our reference value, is included in the solution set, I'm going to use that squared off bracket to close the interval. Now let's look at an interval that has 2 endpoints, 2 reference points. So this compound inequality is showing that all the x's are between -3 and 2. And graphically, here's how I would show the set of numbers between -3 and 2. In interval notation, the -3 is not included, and the +2 is not included, but those are the reference points or the end points of my line segment. So this is how you would express the inequality -3 is less than x, which is less than 2, in interval notation. Here's another compound inequality. We'll look at how to use interval notation to express this compound inequality. -1 is not included in my solutions, but 7 is. So I am putting a point on 7, I'm just circling -1. And then my x values this time are less than the -1 or greater than the 7. Now let's think about where both rays are going. The ray on the right is going toward positive infinity. The ray on the left is going toward negative infinity. And both of these are solutions because in this compound inequality, the solutions can make either problem true and satisfy the compound inequality. So, here's how I would express the interval on the left. Here's the interval notation for the ray on the right, but I've got to show that both of these are solutions for this one problem, and so I show that they are united, that they both are solutions for this compound inequality. So we've looked at how to use squared brackets if you have the or equal to symbol with your inequality. We've looked at using positive and negative infinity to express the ending or beginning of your interval, and how to do compound inequalities as well.